Good morning to you all. Today we start with the first chapter, which is introduction about parasitology. Just a quick introduction. Okay, so let's start. As we said, these are the two reference books, the textbooks in the course. Clinical parasitology and medical parasitology. The first one, clinical parasitology by Tsaipish, this is the one we depend on very much. Although it's 2013, it's a bit old, but parasitology is one of the courses that you have slow modifications and slow updates. Okay, even the other one, which is the most updated, the medical parasitology is 2019. And when you go to Amazon, also you don't have 2023, 24. Okay, this is the latest medical parasitology that fits our purpose. There are others, but we want one that fits our purpose, which is for diagnostic parasitology, to make diagnosis, not just theory. Okay, so these are the two. This is not clinical parasitology is number one, and medical parasitology is number two. Okay. Okay, these here, medical parasitology, we used this 6-7 years ago, but the students complained that the language is too difficult, so we stopped using this. This is by Merkel and Vox, medical parasitology, but still you can go and have a look at it and you can just read it. Diagnostic medical parasitology by Garcia. This is the best. This is the Bible of parasitology. It's almost over 1,000 pages. But this is not for teaching undergraduates. It has everything about theory and it has everything about practice, laboratory tests and techniques and so on. Everything here is detailed. This is if you want to, this is good for undergraduates, good for PhD, postgraduates, masters and PhD. It's the Bible of parasitology, the best you can ever have. They have a abridged version, which is just 200 pages or 300 pages, only for the laboratory tests, laboratory techniques and methods. Okay. See this one. This one is just a summary of, or just includes all the most important methods in parasitology, methodology. The big one, methodology plus theory, both. But I don't recommend this for you as undergraduates. You can go and have a look at it if you want. Okay, you can go to my YouTube. I have many things regarding parasitology. I have the shows, I have videos from my lab. Also, I have lectures, I have videos with narration, without narration, so you can go here. Also, the CDC is a very important reference. Why? Mainly for life cycles. All the life cycles we will come across, they will be based on those from CDC. The only thing we did is that we took these CDC life cycles, which are images only, and we just cut them into pieces and make them animations for you as students to understand. So there are lots of arrows going in and going out, lots of arrows, blue arrows, red arrows. So as a student, as a beginner in parasitology, this animation, which we made from the CDC pictures and images, we made them steps one by one so you can follow which comes first and which comes next. Okay, so you can follow the steps in life cycles, only in life cycles. And it's just music background, no narration. Therefore, each life cycle will be just between 20 seconds and maximum 40, 50 seconds. We have on our channel here no less than 50, 53 life cycles. So these are included in our course. So CDC is a very important thing to follow, very important website. We had this from an Italian website, Atlas. So some of our images and pictures, which we don't have, I mean, you don't expect yourself to have everything. Others will complete your work. One of these websites is this one, the Atlas. I think it's Italian, atlas.protozoa.com. Also, this I use this website. So you can refer to all of these. If you have time, go over them. If you don't have time, you can just go to my channel and that's all. Okay, it depends on how much time you have. We talk about chapter 1. Chapter 1 is just an introduction. It gives you an overview about parasitology. What is parasitology? Let's go. So it's Elizabeth Seibish, although we took it from this book, but also we took some other notes and ideas from other books, okay? But we made this as a main textbook. Parasitology, an overview, a summary, in other words. Somebody might ask us, what is parasitology? You have para, it's a medical term. This is a medical term. You have, let's say, if you want to analyze a medical term, we start with logic, logos, which is science, or the study of, the field of. And then you have parasite. If you want to break it down, you might tell me para means near, next to, and site means the site. So it's something that is near you. It's not something in the core, in the middle, but near you. Okay, that's if you want to break it into para, meaning near or next to or besides, and site and logic. So parasitology. Parasitology is the science that studies parasites, regardless of what these parasites are. These parasites can be human parasites, they can be animal parasites, and they can be plant parasites. But what are we interested in this course? Human parasites and medically important human parasites. We might come across some animal parasites. Why? Because at the end, they affect us. Part of the life cycle is in the animal, and part of the life cycle is in us as humans, or vice versa. So we might come across, we will come across some of the animal parasites because they infect us. What's a parasite? It is an organism living on or in. On or in. It can live on the surface, your surface, like skin or head, or inside us, to get its nutrition. Why do parasites come to us and invade us? Yes, why do they? Because they want to eat. They want to make living, nutrition. Okay, this is the idea. Sometimes it's on the expense of the host, sometimes not. We will talk in a minute about the relationship between parasites and us as humans. So this is a parasite, in or on. So in, sometimes if it's inside us, we are infected with a parasite. If it lives on us, like lies in the head, on the head, we say infested. So there are two terms, infected, infested. Why? Because you might come across these two terms while you are reading. Infestation, infection. Infestation and infection. Three classes, three major or main classes of parasites. Protozoa, as unicellular, single cell. You have metazoa, helminths, that's worms. Protozoa mainly, and majority, they are microscopic. You cannot see them by naked eye. But metazoa, helminths, majority, you can see them by naked eye. Some of them, like, they are 0.1 or 1 millimeter, and some of them, they are 1 meter. 1 meter long. We will come across these during the course. And then arthropoda. Arthropoda, the insects. The mosquitoes, the flies, the ticks, and the lice, and so on. We will not talk about the arthropoda. Just 1 or 2 slides at the end of this chapter, and then we will close the issue. Because this, if we talk about arthropoda, there is another course which is called entomology. Entomology takes care of the arthropoda. You study the mosquitoes and the flies and the ticks and so on and so forth. So these are the three major classes of the parasites: protozoa, metazoa, arthropoda. Types of parasites. People classify parasites depending on many things. So if you look where they live, that's a classification. If you look how they get their nutrition, that's another type of classification. So classifications differ. Let's go to common or commonly used classification. First, types of parasites. We have obligatory parasite. It's a must. This parasite has to be inside a human being. Otherwise, it will not live. It will die. Obligatory. We have facultative. Obligatory, like for instance, parasite like Interamoeba. Interamoeba gets inside us, and then it starts multiplication and nutrition and so on. And when it goes outside, it dies. Of course, some of them will take another form which can resist the environment, which is the cyst. We'll talk about this in the next chapter. Even some people, when I say obligatory parasite, sometimes it's used in virology and used in medical or bacteriology. The word parasite is used in virology. Why? Because virus is a parasite. Virus, when it's outside the human being, it's not living thing. Not living thing. When it gets inside us, like COVID-19, SARS-CoV-2, it becomes active. That's why they tell you viruses are intracellular or they are parasites, or they are not viruses. So obligatory parasite. So parasites, sometimes it's used in biology and used in bacteriology. For those who live outside, they are non-living. Inside our body, they are living creatures. Facultative, in or out. Some parasites, if they find you, then it's okay. They live inside you. If you get rid of them, they will live outside. Endoparasites. Endoparasites, they are inside. See, the other one, obligatory, they live only inside. Here, endoparasites, they can live inside and they can live outside. Not like the first one, obligatory. And we have for the ectoparasites, those who live on our surface, on our skin. Example, the lice. You know the lice? Yes, the lice, sometimes, again, on the surface, yes. Lice is an example. So these are ectoparasites. On the animals, you will see ticks, lots of ticks. They are also ectoparasites. They don't go inside, they just remain outside. So we have obligatory, facultative, endoparasites, and ectoparasites. That's one classification, which is used in the book. We have types of hosts. What do you mean by host? It's us. It's the place or the creature or the living thing that the parasites lives on or gets inside or on the surface. These are one of them, or the first one, incidental. What is incidental? What is incident? Incidental, like accident. Incident, like accident. So these are accidental or incidental. Usually, they live in an animal. Leishmania. Leishmania, it's a parasite. Leishmania usually lives between a victor and a host. The victor is the sandfly, small fly, and the host, the usual host, is the animal, like Pseudomonas obesus, or like Hyrax. But if me as a human being come in the way between the animal and the victor, it can come to me and can create an environment inside me. I am not the original host, but I am what? Accidental host, or better, incidental host. So this is other than the normal host. The normal host in Leishmania is the rodent, like the sand rat or the hyrax. But as a human being, if I come next or across, then they can infect me. I am not the original one, but I am an incidental host. That's one. Then there is a definitive host. What is definitive host? It's the main host. It's the host that holds the adult. You know, some parasites, they are adults. You have stages in the parasite. You have an egg, you have a larva, and you have an adult. So where the adult is the definitive host. Where the adult is the definitive host. Give you an example. Echinococcosis. Echinococcus is a cystode, ribbon-like helmet. Here, usually, we have the dog as the definitive host. Why? Because the dog contains the adult, the worm. The human being or the sheep, usually the sheep, but as a human, we can come as incidental host. We hold the larva. So we are called intermediate. We will talk about these parasites. You don't have to write this. we'll talk about these parasites in details. Each parasite will have a lecture or half a lecture. I'm just giving examples. How an echinococcus, the dog contains the worm, the full worm, adult worm, and the sheep or the human being contains the larva. The dog is the definitive, and the sheep or the human being is intermediate because it contains the larva, okay, or the larvae. So if it contains the definitive, it's sexual, and we'll talk about this in details. Intermediate is the asexual. I'm not going to explain this because you are going to come across this in many parasites until you know everything by heart. Then we have reservoir. It's the parasite tank. Some parasites, this is nature. This is how God created us, or some people believe in nature. So that the parasite does not vanish from the surface of Earth. The parasite does not disappear. It's always there. How? By tanks, reservoir. So the parasite lives in that reservoir, usually an animal, forever. And the victor comes to that reservoir, which might be a mouse, might be a rabbit, might be a hyrax. It lives there, and the victor, like a mosquito or a sandfly, comes to this reservoir, takes blood, and then takes the parasite. And at night, it comes to us and wants to take blood again. And this victor, gives us the parasite. So there is a tank. And usually this tank is a rodent or an animal. This tank, we call it reservoir. Reservoirs means a tank of parasite. Usually these reservoirs are like carriers. Usually they don't show symptoms. If they do show symptoms, the symptoms are mild. Example of the leishmania, we have the reservoir, the hyrax. The hyrax does not show any symptoms. Maybe sometimes on the nose, nostril, they might show some lesions, sometimes. If it shows mild lesions, then we call it reservoir. If it doesn't show anything, and it's totally 100% normal, we call it carrier. So it's just a carrier. Okay, that's the difference between reservoir and a carrier. The carrier, no symptoms at all, and it can infect us. The reservoir, it might show some slight symptoms, mild symptoms, if any at least. Okay, and there is in between, number 5, the victor. The victor, usually, it's the thing that is between us as a human host and the reservoir or the carrier. It goes there, takes blood, and at night comes to our houses and takes blood again. And while taking the blood, sucking blood, withdrawing blood, it gives you the parasite. This is the victor, something that brings the parasite from somewhere into the human being. Victor, by the way, it can be a fomite even. It can be something non-living, needle or something. So the victor is something very general. I mean, people know that victors can be mosquitoes, can be sandflies, can be ticks, but sometimes also fomites, non-living thing, like needles also. Victor is anything that introduces the disease into you, takes it from one place and bring it to you. That's the victor. So types of hosts, which is us, incidental, definitive, intermediate, reservoir, victor, and carrier. So far, so good, ladies and gentlemen. Okay, so when parasite comes to us and wants to make living inside us or outside us, infection or infestation. In some parasites, they come to us and they live, but they don't make any harms. Not only that, maybe they can do some benefits, very little. Okay, so we call this mutualism. Mutualism is you benefit and I benefit. Parasite benefits and I benefit. So if we are both benefiting, like that, for instance, we have bacteria inside our gut, biome. We need this bacteria. Do you think without this bacteria we can live? No. See, so there is some, we benefit and the organism benefits. So if we both benefit, then it's a good relationship, mutualism. You give me something and I give you something in return. So this is a good relationship. Sometimes there is what we call another relationship, it's called commensalism, commensals. These commensals, the parasite benefits, but I as a human being or as a host do not benefit. I don't lose, I don't gain. Okay, I don't benefit, but at the same time, I don't have harm. So the parasite is smiling, or commensalism. The parasite is smiling, and we are not smiling. We are not crying, but we're not smiling. Yeah. Why should you be inside me? I am not benefiting from you. So this relationship, we call it commensalism. And there is the one that parasitism. See, all the time the parasite is laughing or smiling or happy. As humans, parasitism, we are not only not benefiting here, we are getting some damage. So we don't need this. We call this parasitism. If you get damage, if you are not only not benefiting, but also there is damage by multiplication, but this damage does not reach into a state of disease. When this damage reaches state of disease, you are infected and you are losing, your hemoglobin is going down, your tissue is destroyed, then we call this what? Pathogenic. We are frowning here, but here we are crying because the parasite is destroying our systems. If the parasite inside you and starts multiplying and eating your tissue and destroying that tissue and so on, or making swelling, you are losing your eyesight, any damage, then this is pathogenic. So for the host parasite relationship, we have 4 relationships. First is the mutualism, win-win situation. Second, win but not lose situation. Parasitism, win, little bit lose. And finally, it's losing situation, destruction. All the time the parasite is smiling, but the problem is with us. Yeah. So these are the 4: beneficial, neutral, and the expense of, see, you are eating some parasites, you eat and they take your food. They don't destroy you. They just take your food. So you are not benefiting from the parasite, and you are not benefiting from the food you are eating. You are eating and the parasite is taking the food and nutrition. But sometimes the last one, the parasite is getting inside you and it's multiplicating, and not only that, it's damaging, bleeding, multiplication, tissue destruction, tissue enlargement. You can name it. Sometimes you lose your eyesight, everything. Okay. So these are the 4 relationships between us humans as hosts and the parasites. Okay. Look, this is the general life cycle of all parasites. Of course, they differ from one parasite to another. Some parasites, they have simple life cycle, just 2 steps and it's finished. Some parasites, they have complicated life cycle, complex, where you have definitive host, intermediate host, not only intermediate host 1, intermediate host 2. So it's a complicated life cycle. And some, they are very easy and straightforward. This one here, life cycle, just give you the general. Of course, for each parasite, we will explain the life cycle, and then we will go to the CDC life cycles and the animations we made on our channel. Okay, so first here, parasite comes to the human being. This looks like amoeba. Amoeba histolyticum comes into the human being and it's eaten. Usually when it's eaten in the form, when you just, let's say, drinking and eating, and then we get parasite. The form which gets inside us and later on causes the infection, we call it infective stage. This stage is the infective stage. Here, entamoeba usually does not come inside us in this form. It comes inside us in the form of cyst. We'll talk about entamoeba next chapter. So parasite enters the human. Then what happens? When it gets inside us, it makes resonance, which means it's going to establish itself inside our intestine, for instance. And this is what happens. So this parasite, which we got inside us in the infective form, will take refuge inside our intestine, and there it will start multiplication. Look, shape changes, course. In Amoeba histolytica, this is going to be here like a bowl, hard bowl, very hard shape. And when it gets, that's the shape. And when it gets inside us and in the intestine, this bowl will break out and transform into another shape, which we call trophozoite. So there is a shape change most of the time. Why? Because this hard bowl outside, it resists the environment. But when it feels that it's inside you and everything is soft and it's protected and nothing, no harsh environment, then it takes off its coat and starts eating. Okay, so they change shape, most of the parasites. That's normal. So parasites multiply. When it changes form, starts eating and starts multiplying into millions. Sometimes the parasites, they decide that for one reason or another, they want to go outside you. So these parasites, when they go outside you, they just what they do, they go out of the anus, or they change shape, which is the hard shape, which they entered like this here, which was the cyst at the beginning, and then they go outside you. They go outside you. When they go outside the human being in the stool, it becomes diagnostic, because in the stool, you can take small amount under the microscope and you can see there's two stages. Like Amoeba here, in the case of Amoeba, you can see trophozoite, which will die in 1 hour, 2 hours maximum, and the cyst stage, which will remain until they invade another host. So here, diagnostic stage. So we have in each parasite, in every parasite, we have infective stage and diagnostic stage. So this parasite, when it goes outside, these two forms, the form that was multiplying inside you, which is delicate and sensitive, delicate and sensitive, outside, sun, pH, cold, all these harsh environmental conditions, they kill this parasite. But the infective form, which is very hard and very strong, and it can resist, very resistant, then they remain. They remain outside in the soil. And these here, the hard ones like cyst, they find their way in one way or another into your water again, into your food cycle again. And then you or somebody, another human being, can get infected by drinking contaminated water, eating contaminated food, and so on. So this is what's going to happen. They find their way inside the food chain, your food chain, and then they change shape. Of course, they change shape here. In the cyst of Amoeba, they change shape here, some of them. Before they go out of you, they start shape. They sense by pH, oxygen requirement, and other techniques, they sense that they are going out. And if you are going out while it's raining, you have to wear your coat. And that's what they do. They change shape because they sense that they're going out into harsh environments. See? So we have part of the life cycle inside us and part of the life cycle outside us. This is the simple life cycle. There is sometimes you have another life cycle for the same parasite where it is in a fish or it's in a cow. So it's in the environment, in a fish or a cow, then it comes to you. Without going through the fish or the cow or the lobster, they cannot infect you. If you take the parasite directly, you will not be infected. It has to go through the other host. But we don't show this. We will show this in every parasite. This is what we call simple life cycle. It's a general simple life cycle like the amoebas. Amoebas are like this. Okay, I think we can stop here for today. Any questions? Okay, we will continue next lecture. Okay, have a nice time and thank you for today.